Hello everyone, and welcome to the solution for the anagram problem in the array sequence section of the course. As always, there's a full notebook of the solution, and it explains every step of the way, as well as gives you the code that we're going to go through in this video. So, to start off with, there's two ways of thinking about this problem. First off, if two strings have the same frequency of letters or elements, meaning each letter shows up the same number of times in both strings, then they are anagrams of each other. On a similar vein of that logic, if two strings are equal to each other once they are sorted, then they are also anagrams of each other. So let's go ahead and implement the second solution first, since it's the easier one of the two. So we'll go ahead and make our function anagram. Takes in two strings, s1 and s2. And then what we're going to do is just remove spaces and lowercase all the letters. So I'm going to say replace. And what this replace method does, it's a method on a string, and it says basically replace all white space right here, a single white space with no space. There's no space between those single quotes. And after that, I'm also going to lower it. So let's go ahead and copy this line, and then just change it to S2. So what we're doing now is just taking the strings, both of them, and reassigning them to remove all the white space and then lowercase all the letters. After we've done that, we can simply return a boolean for the sorted match. So I can say return sorted S1 double equal sorted S2. So all I'm doing right now is I'm just comparing the strings that we've replaced after we removed the spaces and lowercase letter. I'm saying if they're sorted and then they're equal to each other, then we know they're anagrams of each other. So let's go ahead and test this out. We have anagram. Let's go pass in God, or whatever. God, and let's say dog. And that's true. Let's go ahead and pass in, let's say, Clint Eastwood, the example from the problem notebook, Clint Eastwood. And we'll do Old West action. So notice how there are different amount of spaces. The first one has one space. This second one has two spaces, but that won't matter because we had this replace method in there. And if we run that, that's true. If I add another letter in, it becomes false. So we know the solution's working. Great. So this sorting method is actually really quite simple, but it's not the optimal way. And in an interview setting, you're probably going to be asked to implement a more manual solution involving just counting the number of letters in each string to test your ability to understand hash tables, which we go over later on in this course. So what we're going to do is build out a fuller solution using counting and Python dictionaries. So let's go ahead and call this anagram 2. We're going to do the same thing to start off with. Remove the spaces and lowercase the letters. And then we're going to start off with an edge case check. So I'm going to say edge case check as a comment. What I want to do is check if they have the same number of letters. If both strings don't have the same number of letters, we can immediately say it's false, it's not an anagram, since they need to have at least equal matching number of letters. So I can do this by saying if the length of S1 doesn't equal the length of S2, return false. Okay, so let's go ahead and continue on. Next up, we're going to create a counting dictionary. So we could use a default dict from the collections module, but so that we don't use any special modules in Python, we're just going to use a straight up dictionary. Call it count. So we're basically just going to count the frequency of each letter appearance and then check that all the counts are the same. So what we're going to do is fill the first dictionary with the first string, and then fill a dictionary again for the second string, but subtract counts. So the first time around we're going to add counts for each letter. Second time around we're going to subtract counts. And then if we check that all the counts are equal to 0, we know they're anagrams. So let's go ahead and code this out so it's a little bit clearer. So I'm going to say for every letter in S1, that's string, if letter in count, then I'm going to say count letter of that key plus 1. Else count letter equals 1. Okay, so what is this doing here? I'm saying for every letter in that first string, if the letter is already in my dictionary, then add 1 to that key, that letter key there. So as we go along, let's say it's Clint Eastwood. So I see C. Then I say if letter is in count, well, actually C, since it's the first letter as we go along the string, it's not going to be in count yet. So we're going to say else, and that's where I set this. I set count of that letter, which happens to be C. So at that key C, we're going to set it equal to 1. And then we're going to basically do the reverse for the second string. I'm going to say for letter in S2, if letter in count counts letter, I'm going to say -1. Else count letter is equal 1. And now I just want to check that all the counts are 0. So for k in count, if count of k, let's go ahead and zoom out a little bit. If count of k is not equal to 0, I'm going to return false. Otherwise, they're anagrams, so I can just say return true outside of that for loop. So let's go ahead and make sure this solution works. Let's fix that. Okay, so if I call this anagram 2, then we run it. Still false, that's good. Let's see if it works here. And it's true. Great. So a quick note on this second solution. Again, the use of a default dict form from the collections module in Python would clean up this code quite a bit by not having to do these checks. But the thing is, we don't want to use things that might only be specific to Python, so we'll make sure to count out every step. One other thing that might clean up this code, you could technically put in this into the second for loop and build it in, but I quite like this solution because it's really clear what we're doing here. So again, let's just go over each of the steps. Should be your preferred solution if you get asked this in an interview setting. So to check if they're anagrams or not, first off, we clean up the strings. We lowercase all the letters, remove any white space. Great. We do an edge case check. So this should quickly tell us if they're anagrams or not. So we do if length of S1 isn't equal to length of S2, return false. Otherwise, we have a possibility of an anagram. So moving along, we create a dictionary called count. Then for every letter in that first string, if the letter's already in our counting dictionary, we're just going to say count at that letter, so that key, add 1 to that count. Otherwise, set it equal to 1. For letter in S2, which is that second string, do the same thing, but now we're going to be subtracting. So if letter in count, then we're going to subtract 1 from it. Else, that count of that letter is equal to 1. And this is the setting right here that's basically going to trip up this third for loop in case it's not an anagram. That's why this is, again, a positive equal to 1. So this is what's going to be going off if this is not an anagram, along with this as well. So then it says for k in count, if count of k is not equal to 0, return false. So if it's an anagram, then this line should have occurred as many times as this line. All right. Hopefully you understand. Should have been pretty straightforward. Go ahead and code this out. The tricky part to this question, actually, is having to do this by hand. It's a lot tougher, so I recommend that you go ahead and take out a pen and paper or a whiteboard and code out the solution by hand. All right. With that being said, thanks everyone, and I'll see you at the next lecture.